We're going to talk about the alternate exterior angle theorem. The alternate exterior angle theorem says that if two parallel lines are intersected by a transversal, then alternate exterior angles are congruent. And here we're told that line W is parallel to line X and that line Z is a transversal. Okay, and so we're trying to prove that that angle 1, this angle here, is congruent with angle 8. Okay, so we're going to start by writing our given statements. We know that line W is parallel to line X, and this is our given. Okay, and again, you can put that line Z as a transversal, but that's really the biggest part of that is that it tells us about our corresponding angles. Okay, so now we need to figure out how to incorporate angle 1 and angle 8 into our proof statement or our justifications. So we can look at this and say that angle 1 is in a corresponding location with angle 5. Okay, so if we do that, we know that if two angles are in corresponding, if they're corresponding angles, then the angles are congruent. So we can say that angle 1 is congruent to angle 5 based on the corresponding angles postulate. Okay, so what we have right now is that, angle 1 is congruent to angle 5, and we've said that's by the corresponding angles postulate. Now, what is the relationship between angle 5 and angle 8? Well, we know those are congruent based upon the vertical angle theorem. So we can say in our next step that angle 5 is congruent with angle 8 based on the vertical angle theorem. Okay, and what we're trying to prove is that angle 1 is congruent with angle 8. Well, if angle 1 is congruent to angle 5 and angle 5 is congruent to angle 8, we can say by the transitive property that angle 1 is congruent to angle 8, and that would be by the transitive property. Okay. Great. Okay, the next theorem that we're trying to prove is the same side interior angles. If two parallel lines are intersected by a transversal, then interior angles on the same side of the transversal are supplementary. Okay, so we're going to be looking at angles 3, angle 3, and angle 5 here. But we could have also been looking at angle 4 and angle 6. Okay, so we're not saying that these angles are congruent to each other, so I'm going to get rid of the markings. But these are just the angles that we're interested in. We're interested in angle 3 and angle 5. Okay, so our first step is to state our givens. And our givens are that line W is parallel to line X. And that's our given statements. Okay, and now we're trying to prove that angle 3 and angle 5 are supplementary angles. Okay, so where can we start? We need to include the angles that we're trying to prove. So we could start with something that includes that angle 3. So let's look at angle 1 and angle 3. What kind of angles are angle 1 and angle 3? Well, angle 1 and angle 3 are a linear pair. And we can see this on our chart here. Or on our figure. We can see that they're adjacent angles whose non-common sides form a straight line. Okay, so based on that information, we can say by definition of linear pair. Okay. And then we can say that angle 1 and angle 3 are supplementary angles. and that's based on the linear pair postulate. Okay. And now we know that the measure of angle 1 plus the measure of angle 3 equal 180 degrees, and that's by definition of supplementary angles. And it's really much easier if I zoom in here and try to write. It makes my handwriting much better. Okay, so if the measure of angle 1 plus the measure of angle 3 equal 180 degrees, we need to try to include the angle 5. And what do we know about the measure of angle 1 and the measure of angle 5? Well, 1 and 5 are in corresponding locations. So we know that those two angles are congruent to each other. So we can say that, that angle 1 is congruent to angle 5 based on the corresponding angle postulate. Well, if they're congruent to each other, we know by definition that the measures are the same. So we can say the measure of angle 1 equals the measure of angle 5, and that's by definition of congruent. Okay, and now we can see that we can replace. Okay, so we want to replace the measure of angle 1 here, and we can see that it's the measure of angle 1 here, and it equals the measure of angle 5. So we can say that the measure of angle 5 plus the measure of angle 3 equal 180, and that's going to be by substitution. But that's not quite what we want. We want to say that these two are supplementary angles. So can we say that based on the measure of angle 5 plus the measure of angle 3 equaling 180? Well, based on the definition of supplementary angles, we can say that angle 5 and angle 3 are supplementary angles. And that's based on the definition of supplementary angles. Okay, so same side interior angles. We have just proven that same side interior angles theorem, and this should say theorem up here, theorem, which states that if two parallel lines are intersected by a transversal, then interior angles on the same side of the transversal are supplementary. Okay, and the last theorem that we're going to prove right now is the same side exterior angle theorem, and we're using a lot of the same information that we just did. It states that if two parallel lines are cut by a transversal, then the exterior angles on the same side of the transversal are supplementary. So here we're proving that angle 1 and angle 7 are supplementary angles. So we're looking at angle 1 here and angle 7, and we're proving they're supplementary angles. Okay, so we're going to start by saying that line W is parallel to line X, and this is given information. Okay, and then we need to somehow incorporate these angles into our proof. Okay, so we've got our statements on the left side. And our justifications on the right. Okay, so we can start by looking at angle 1 and angle 3. And what do we know the relationship is between angle 1 and angle 3? Well, they're a linear pair. Okay, so we can say that angle 1 and angle 3 are a linear pair, or form a linear pair. So we can say that angle 1 and angle 3 form a linear pair. And that's by definition of linear pair. And we can say that angle 1 and angle 3 are supplementary angles. And that's by the linear pair postulate. And then we can say that the measure of angle 1 plus the measure of angle 3 equal 180 degrees. And that's by definition of supplementary. Okay. And now that we've gotten that far, we need to somehow incorporate angle 7 in here. Okay, because we're as far as we can go, I think, with angle 1. So what can we do with angle 7? Well, do you notice that angle 3 and angle 7 are in corresponding locations? So because they're in corresponding locations, the corresponding angle postulate says that these two angles are congruent to each other. So we can say that angle 3 is congruent to angle 7. So we can say angle 3 is congruent to angle 7, and that's by the corresponding angles postulate. Okay. And by definition of congruency, we know that means that the measure of angle 3 equals the measure of angle 7. So that's by definition of congruency. Okay. And then we can replace. And we're trying to work with the measure of angle 1 and the measure of angle 7 and prove that these two angles are supplementary angles. So do we see here the measure of angle 3 is equal to the measure of angle 7? So why don't we use some substitution? So we can say the measure of angle 1 plus the measure of angle 7 equals 180 degrees. And this is by substitution. And we're substituting in steps. This is 1, 2, 3, 4, and 6. Okay. And then by definition of supplementary, we can say that angle 1 and angle 7 are supplementary angles. And that's by definition of supplementary. So we have now proven all of these theorems that you can find in your chapter 2 of your textbook, but maybe not in chapter 2 of the next textbook. So they're all the theorems that deal with parallel lines cut by a transversal. Okay, so I hope this helps, and if you have any questions, please be sure to ask.